this first experiment that we're going to be doing in chemistry this summer, we're going to be focusing on how to take measurements properly. The digits that you write down for a measurement are very important. Every digit has meaning. Too many digits provide meaning that you do not know. The first thing I want to point out is the difference between what a measurement is and what is an exact figure. Both of these are composed of numbers. However, the meaning is completely different. So in my hand, I have two rulers. I have two 100 milliliter beakers. I have one 100 milliliter graduated cylinder. Each of these facts is composed of a number that has a meaning, and each of these numbers represents an exact quantity. Things that you can count are exact. However, a measurement, in order for it to be taken, you have to have some kind of measuring device. All measurements are composed of a number where the values are based on the numerical position. Whichever device you use, whether it's digital or some kind of device with lines, there is some kind of uncertainty. There's only so much that that device can tell you about whatever measurement you're taking. The way that we know this uncertainty and this known information is based on what we see and what device we're using. If it is a digital device, all of the values that you see displayed on a digital display, such as our balance, you will record all of the values. When you record a measurement where it is in digital form, all of the values that you see are known up to the last digit, which is considered to be estimated by the device. So if we take a look at our balance, you will see that there are numbers that go all the way to the 1000th place. There will always be a number displayed in the 1000th place, and that will be the last digit. The last digit is the estimated digit. So when you want to record a measurement, if you want to record the measurement of an object, the first thing that you'll do is hit the 0 button. Even if you see 0, you still want to hit the 0 button. Then you place the object directly in the center, and then you wait. And what you'll see on display are the digits. So you would record 49.635 grams. And there it just fluctuated to a 6. So I'm going to record 49.636 grams as the measurement for this 100 milliliter graduated, or this 100 milliliter beaker. I'm going to record that in my data table, which for our video here is going to be on this board. And so in a data table, you will see a description. When you record a measurement, you look for the description of the measurement that you just recorded. So I just recorded the mass of a 100 milliliter beaker. So in the space beside of it, I'm going to write down 49.636 grams. So I have all of the values that I saw. When you look at any measurement, this is based on the balance. The last significant figure is the estimated digit. So that balance is able to estimate to the 1000th place. You have to put all of the known, which every number before that is the known digit, estimated as last, and then you put the unit so you know what the 49.636 means. So that is 49.636 grams. When you are dealing with things with lines, such as the graduated cylinder, the beakers, and a ruler, each of these measuring devices has lines. Now we can use these devices just to hold material, but if we want to use it to actually measure the material we put inside of it, then we look at the lines. Every line, whether it has a number next to it or not, is a known quantity. So those are known parts of the significant figures. So I'm going to pour some green apple Gatorade into this beaker. Then I'm going to set it down. So you want to set it down so that you can get eye level when you're trying to record a volume. So here is the solution of Gatorade. And if you notice, you will see that there's a 40 and a 60, and in between it, there's a line. So if there is a 40 and a 60 number in a line in between, the line is 50 milliliters. And our green apple volume is between the 50 and the 60. So because there's a line, the line is what we know about this volume. This volume is somewhere between 50 and 60. And so you record that known digit. So in my data table, I have volume of Gatorade in 100 milliliter beaker. And so I'm going to put that I know it's at least 50. But then whenever you record a measurement, the next digit that you record is going to be what you estimate. So the 50 is based on the lines that are on the device, which is known. And then I'm going to guess at how close it is between 50 and 60. So if we look at it, we can see that it is closer to 60 than it is 50. And so I'm going to guess that it's a little more than halfway. And so I'm going to guess that it's 57. That's estimating. You may estimate that is 58 or 59 or 55. All of those will be considered correct because you're estimating, you're doing your best guess based on what you see and what you know. And so what we know again is that it's between 50 and 60. And then we just have to estimate whether we think it's more than halfway, or less than halfway. So I'm going to record my volume. This is a measurement. These are significant figures, which gives me the value of my measurement. Significant figures are composed of all of the known information, which on line devices are the lines, followed by one estimated digit where you physically estimate, versus balance, which the balance estimated for you, you just had to correctly write down what you saw. The last digit on any measurement is the digit that is estimated. If I take some of this Gatorade and I pour it into the 100 milliliter graduated cylinder, the process is the same. So I'm going to look at the lines And we can see that there's a 60 and a 70, and there are lines in between it. Every line means 1 milliliter. And so therefore, since the lines mean 1 milliliter, I will know that this volume is between 60 and 70. I'll know that it's 60. I'll also know which 1 milliliter increment it's part of based on the bottom of the meniscus. So if we get eye level and we look at the bottom of the meniscus, you rotate it around so that you can count the lines. And so we have 1, 2, 3. It's between the 3 milliliter and 4 milliliter mark. So therefore it is 63, and that part is known. So I'm going to place that information where it says volume of Gatorade in the 100 milliliter graduated cylinder. So I saw that it was 63, and those are known because of lines. And then I'm going to estimate the next digit, which is the 10th place. So I'm going to just estimate, do I think it is close to the 63, or is it closer to 64? So you want to get eye level with it. And to me, it looks like it's just above 63. So I'm going to estimate that it is 63.2. Again, all of the values that you write down are part of the measurement. Known, known, estimated. Known, 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 estimated. This last position is the estimated, which is the degree of precision. Anything past this would be more precise, but completely uncertain. There's no way for us to estimate anything further than between 2 lines. The last device that we're going to look at for the Prelab video is the ruler. We use centimeters, so don't even turn it around to the inches. But the centimeters, we're going to record things in centimeters, so every one of these has 1, 2, 3, 4, 5, and there's a 0, and the 0 is not at the end, but just slightly over. The good thing about these rulers is that they are clear, so you can see through them. So whenever you want to measure something, you want to place it directly on top of it, because you can see through it, and it's easier to line them up and see where the end of what you're measuring falls. So I have a Post-it right here. So I'm placing it on top of the Post-it. So not the side of it where I'm trying to see where it is, but directly on top of it because I can see through it. You want to line up the end of the Post-it with the 0 line. And so there's 2 lines so you can get it square. Then you come over to the other end. And if you look, you'll see there's 6, 7, 8. And then in between the 7 and the 8, there are lines. Every line is a 10th. So since the lines mean a 10th, I know the 7 and I'll know how many tenths there are. So it looks to me like it is between there's the 0.5, 0.6. It looks like it's between the 0.7 and the 0.8. And so I'm going to write down that I know there's the length of the Post-it. I'm going to write down the known line information, which is 7.7 7. This is going to be centimeters. And I'm going to guess how close it is to the line. And so it looks to me like it is just over the line. So I'm going to guess that it is 7.71. If I thought that it was on the line, then I would put 7.70. So significant figures, because there's a decimal point, it's the first non-zero number. And then because there's a decimal, it's the last number, whether it's a 0 or not. So if I put a 0 there, it's still showing the precision because that position there shows the precision. But each of these measurements that I recorded, each of them has some degree of uncertainty. So therefore, no measurement is exact. Exact are things that are counted. No measurement is exact. Each of these measurements has some uncertainty, and if you are uncertain about a number, you cannot say that it's exact. Just to show you for a moment what the experiment looks like. There's a background. I explain again significant figures, which we talked about in class, the different kinds of devices. I show you an example of how you can read the volume. The pre-lab questions, you want to answer these. Type of measurement, these are the types of measurement: mass, volume, temperature, time, length. The way that you know the type of measurement is based on the unit. And so in the type of measurement column, you're going to put what kind of measurement. So don't put that as milliliters, you would put that's a volume, because milliliters is a volume unit. And then the next column, what position for the estimated, that's the last digit. Whenever it's a measurement, all of these are measurements. Whatever the last digit is, that last digit is going to be the estimated digit. So you name that position. So don't say 6. That 6 is in the 10th place. So what goes there is the name of that, the numerical name. So just as a review, 10's place, 1's place, 10th, the next would be the 100th, 1000th, 10,000th. So that's the information that would be there. Then this is also part of the pre-lab. This is data. So you have the mass of a dish, the mass of a dish in calcium, the mass of a dish in calcium oxide. So see if you can use this data that you would record to figure out how much does just the calcium weigh and how much does just the calcium oxide. So pay attention to the words, find what word you want up top and see how you would have to figure it out. This here is an example of what's called mass by difference, where you would measure the mass of the container and then put some chemicals in it. And this is a common way that we measure mass, because we have to have, for chemicals, they have to be contained in a dish. And then the procedure that you're going to do together, here's another example. These are measurements that are taken. You're going to take these measurements at different stations. And then you're going to measure the volume and the mass of rock by measure the volume by submerging the rock into water. So this is the experiment that you need to read over. As you read over it, each of these, you want to think about what it's saying to do. Try to envision yourself doing this. Think about what's important for the measurement. But this experiment is simply a way for you to practice taking measurements correctly, working together with someone, and also following a procedure. Do you notice that I have my safety glasses on, even though I was just measuring out Gatorade and measuring the length of a Post-it? As soon as you come into lab, you'll put your safety glasses on and leave them on for the duration of the experiment. See you next week.